Hello, sir. First of all, good morning to one and all. This is Kenishit. I am from ECB section. My roll number is 21951804C4. Welcome to my presentation. Today's my subject is mathematical transformation techniques, and today's my topic is multidimensional multidimensional Fourier transform. First of all, we know about Fourier transform. Multidimensional transforms are used to analyze the frequency content of signals in a domain of two or more dimensions. Multidimensional Fourier dimensions. One of the more popular multidimensional transforms is the Fourier transform, which converts a signal from a time-space domain representation to a frequency domain representation. The discrete domain multidimensional Fourier transformation FT can be computed as follows, and the formula is f of w1, w2 and wm is equals to segmentation of n1 is equals to infinity to infinity. The limits are into infinity. F of n1 comma n2 comma n plus mth term e power minus I w1 n1 minus I w2 n2 equals to minus wm n1, where f stands for the multidimensional Fourier transform and m stands for the multidimensional dimension. Define f as small f as a multidimensional discrete domain signal. The inverse multidimensional Fourier transform is given by f of n1 n2 comma n plus n term so on to mth term is equals to 1 by 2 pi whole power m is limits of minus pi to pi or so on, limit of minus pi to pi. Capital F of w1 w2 and w2 and so on to mth term e power n I w1 n1 plus I w2 n2 plus so on w2 mth term dw1 to so on mth term. The multidimensional Fourier transform for continuous domain signals is defined as f of ohm1, ohm2 and ohm2 mth term is equals to limitation of infinite to infinite f of t1, t2 and tm term e minus I ohm t1 minus ohm2 t2 minus ohm m2 mth term d1 d2 mth term. Properties of Fourier transform. Similar properties of 1D FT, one-dimensional Fourier transform apply, but instead of the input parameter being just a single entry, it's a multi-dimensional MD array or vector. Hence it's x of n1 plus n term instead of xn. If x1 is n1 so on n mth term, ft x1 of w1 so on wm and x2 n1 so on nm, ft x2 w1 to so on wm. Then modulation is f1 if x is x or x into n1 so on nm, ft x into capital X into w1 so on wm. Then the formula is e power j of theta 1 n1 plus so on 2 plus theta m nm small x into n1 minus a1 nm minus am ft capital X w1 minus theta 1 wm minus theta m. Multiplication of this equation is if x1 is n1 m1, so then the Fourier transformation, the next step is Fourier transformation x1 capital X1 of w1 so on to wm, and the x2 is n1 to nm. By adding the Fourier transform, capital X2 is equals to w1 to, here the capital X1 is changing to x1 and x2, then x1 of n1 so on nm, x2 into n1 nm, Fourier transforms 1 by 2 pi m, limitations of minus pi to pi x1 w1 into theta 1 of w1 minus theta m of x2 minus theta 1 by theta m, or x1 of n1 so on nm of x2 of n1 nm, Fourier transforms by 1 by 2 pi whole power m, limitations of minus pi to pi x1 is theta 1 so on to theta m, x2 is w1 minus theta 1 so on to wm minus theta m. Differentiation this by the different what is the Fourier formulas of differentiation. If x into n1 so on to nm, by the adding of Fourier transform equation, x of w1 wm, then minus j n1 x say n1 so on to nm by ft, dou by dou w1 x w1 to wm minus j n2 x of n1 to nm, if by considering the Fourier transformation equation, dou by dou w2 equals to x1 minus x1 minus jm n1 by n2 is equals to 1 to nm, x of n1 equals to nm, ft of dou whole power m by dou wm dou w2 by dou wm, x is equals to 1m to so on to wm. Transposition, if x of n1 is nm ft, the w1 is so on to wm, then the x is nm to n1 ft is wm to w1. Reflection is, if x of n1 nm, Fourier transformation x of w1 so on to wm, then x is plus or minus n1 equals to plus or minus n1. Considering the Fourier transformation equation, x of plus or minus w1 is so on to plus or minus wm. Complex conjunction, it is x of n1 n1, Fourier transformation x is w1 by wm, then the x into plus or minus n1 so on to plus or minus nm, and x into w1 minus 1 minus wm. Parseval's theorem, multidimensional, if x1 of n1 so on to nm ft, x1 is omega 1 so on to omega m, and the x2 n1 m2 is to x capital x2 omega 1 to omega m, then the equation is n1 is equal 0 by 0, n1 equal minus infinity, x1 of n1 to nm, x2 into n1 nm is equals to 1 by 2 pi n, and the limitations of minus pi to minus pi to pi, x1 is equals to omega 1 so on to omega m, x2 into omega 1 m so on to omega m, dou omega 1 so on to dou omega m. If x1 of n1 is omega 1 is equals to x2 of n1, then the equation is integration of infinity to so on to nm by minus infinity, x1 of n1 of nm mod 2 mod power mod square and 1 by 2 pi m is equals to x1 omega 1 omega m to mod square. a special case of Parversal theorem in when the two multidimensional signals are the same. In case the theorem portrays the energy conversion of a single and the term in the summation separability. One property is a separability property. A signal or system is said to be separable if it can be expressed as a product of 1D function with the different independent variables, in which phenomenon allows computing the FT transform as the product 1D FTs instead of multidimensional FT. And multidimensional Fourier transformation, fast Fourier transformation. A fast Fourier transformation is an algorithm to compute the discrete Fourier transform DFT and its inverse on a FFT computes the DFT and produces exactly the same result as evaluating the DFT in definition directly. The only difference is that the FFT is much faster. In the presence of the round of error, many FFT algorithms are also much more accurate than evaluating the DFT definition directly. There are many different FFT algorithms involving a wide range of mathematics, from simple complex number arithmetic to group of theory and number of theory. MDDFT, the multidimensional discrete Fourier transformation, is a sampled version of the discrete domain FT by evaluating it as simple frequencies that are uniformly spaced. The n1 into n2 into n power m DFT is given by. So thank you, sir, for giving this wonderful opportunity.